Ever been deep into a conversation with ChatGPT, like 20 messages in, and suddenly it's like it has amnesia? You ask it to remember something from the beginning, and it just gives you a blank stare. It's frustrating, right? It feels like you've been talking to a goldfish. Well, what if I told you this forgetfulness isn't a bug, but a fundamental feature of how these AI models work? Welcome to episode 38 of our series, where today we're redoing a deep dive into one of the most crucial concepts in large language models. The context window. Think of it as the AI's short-term memory. We'll explore what it is, why it matters, and how it's shaping the future of artificial intelligence. So what exactly is a context window? Imagine you're packing a truck. This truck represents the AI's memory. Everything you say to the AI and everything it says back to you is like a box that gets loaded onto this truck. The total amount of space inside the truck is the context window. Now, let's say your truck has a capacity of 4,000 units. In the world of AI, we often measure this in tokens, which are roughly words or parts of words. So a 4K context window means the AI can remember about 4,000 tokens of conversation at any given time. Here's where it gets interesting. What happens when your conversation gets really long and you try to load more boxes than the truck can hold? Well, something has to go. The truck driver, in this case the AI, will start throwing out the oldest boxes from the back to make room for the new ones at the front. This is exactly why ChatGPT seems to forget the beginning of a long conversation. It's not being difficult. Its memory truck is full, and it had to discard the earliest parts of your chat to process your latest message. This first-in, first-out system is a core design constraint. The context window isn't just about chat history either. It includes the initial instructions you give the model, any documents you provide for it to analyze, and the entire back and forth of your dialogue. Everything gets packed onto that truck. Now, you might be thinking, why don't we just build bigger trucks? And that's exactly what's happening. A few years ago, a 2K or 4K context window, like in early versions of GPT-3, was standard. That's like a small delivery van. It's good for quick, simple tasks. But for complex, long-term projects, you need something bigger. Today, we're seeing models like GPT-4 Turbo with a massive 128K context window, and Google's Gemini 1.5 Pro boasts a staggering 1 million token window, with promises of even more. A 128K window is like a semi-trailer. You could fit the entire text of The Great Gatsby into it with room to spare. A 1 million token window? That's a whole convoy of trucks. You could load several novels, a full codebase, or hours of video transcripts, and the AI could reason across all of it in a single go. This expansion has huge implications. Imagine feeding an AI your company's entire financial history for the last decade and asking for a detailed analysis of trends. Or giving it a whole programming project's codebase to find bugs and suggest improvements. With a large context window, the AI has all the necessary information on the truck at once. It can see the big picture, connect distant dots, and maintain coherence over incredibly long interactions. This is a game changer for professionals in fields like law, medicine, and finance, who often work with massive documents. Instead of breaking a book down into chapters for the AI, you can just give it the whole book. But here's the catch. Bigger isn't always better. Operating a giant semi-trailer is much more expensive and slower than driving a small van. Larger context windows require exponentially more computational power. Processing 1 million tokens takes a lot more time, so we have these trucks of varying sizes. But even with the biggest truck, what happens when you have a conversation that is truly endless, or a project that goes on for months? Sooner or later, even a 1 million token window will fill up. How do we solve this problem of long-term memory? This brings us to some clever packing techniques. One popular method is summarization. Imagine that after every few miles, the truck driver stops, takes a bunch of similar small boxes, and packs them neatly into one larger, more compact box with a label summarizing the contents. This is what summarization techniques do. Periodically, the system will take a chunk of the older conversation, create a concise summary, and replace the original text with that summary. This frees up a lot of space on the truck, allowing the conversation to continue much longer before things start getting thrown out. The downside, of course, is that summaries can lose detail. A label that says boxes of kitchen supplies isn't as informative as seeing each individual box for the can opener, the plates, and the coffee maker. If you later ask the AI a very specific question about an early detail, it might not remember because that detail was lost during compression. It's a constant trade-off between memory efficiency and information fidelity. Another, more advanced technique is something called retrieval augmented generation, or RAG. Let's go back to our truck analogy. What if, instead of trying to fit everything on the truck, we had a massive external warehouse right next to our route? This is the core idea behind RAG. The warehouse is a vast database of information. It could be the entire internet, your company's internal documents, or your personal notes. When you ask the AI a question, it doesn't just look at the boxes currently on its truck, the immediate context. It first sends a quick query to the warehouse to find the most relevant information. It's like the driver radioing the warehouse manager and saying, "Hey, the customer is asking about the delivery from last March. Can you pull up the records for that?" The warehouse manager finds the specific documents and sends them over. The AI then loads this retrieved information onto its truck, right alongside your current conversation, and uses all of it to formulate a much more informed and accurate answer. This method is incredibly powerful. It allows the AI to access a virtually unlimited amount of knowledge without needing an infinitely large context window. It effectively gives the AI a long-term memory. It can pull in up-to-the-minute information, reference specific details from documents it's never read before, and ground its answers in factual, verifiable sources. This is how many sophisticated AI assistants, like Perplexity AI or custom enterprise chatbots, are built. They combine the reasoning power of a large language model with the vast information storage capacity of a retrieval system. It's the best of both worlds, a smart, agile truck with access to an enormous warehouse. So, to recap, the context window is the AI's active memory, like the cargo space in a truck. It has a hard limit, and when it gets full, old information is discarded. While companies are building bigger and bigger trucks, larger context windows, this comes with significant costs in speed and computation. To work around these limits, we use clever techniques. Summarization acts like compressing cargo to save space, but it can lose detail. And retrieval augmented generation, or RAG, is like having an external warehouse, giving the AI access to a near-infinite long-term memory by retrieving relevant information on demand. Understanding the context window is key to using AI effectively. When your AI seems to forget things, you now know why. It's not a flaw, it's a design constraint of the truck it's driving. You can help it by keeping your conversations focused, providing clear context, and, if you're a developer, by implementing smart strategies like RAG. The future of AI isn't just about building bigger models. It's about building smarter systems that can manage and access information efficiently. The interplay between the immediate memory of the context window and the vast knowledge of external databases will define the next generation of intelligent assistants. It's a fascinating engineering challenge, and as these systems evolve, they'll become even more capable and reliable partners in our work and daily lives. Thank you so much for joining me on this deep dive. I hope this truck analogy helped demystify the concept of the context window. If you found this explanation useful, please hit that like button and subscribe for more insights into the world of AI. Let me know in the comments what other AI concepts you'd like to see explained. See you in the next one.